Hello, math humans. We're going to do 10.4 today. We're going to be talking about our conic section hyperbolas. So our objectives are that we're going to find or develop the hyperbola equations and talk about vocabulary words, foci, asymptotes, and the transverse axis. So just like we've done with all of our other conics, we're going to talk about its definition. So it is the set of all points in a plane, the difference of whose distances from two fixed points, called the foci, is a positive constant. So the hyperbola, again, remember, all of our conic shapes are coming from taking a plane and running it through a cone at a specific angle, and it creates a different shape. So the hyperbola is still something that's coming from our cone, which is why it's called a conic section. So the first thing that we're going to talk about is the horizontal hyperbola. So we can get kind of all of our definitions and equations and things. So here's going to be my coordinate system. Okay. So I'm going to have a vertex and a vertex. So it has two vertices. So I'm going to label this V and this V. Hyperbolas are cool because they have asymptotes, okay, that push the shape of the curve. So I get my little asymptotes in there. And my asymptotes are going to be y is equal to plus or minus b over ax. So let's have a conversation about what your book does and what I'm going to expect you to do. So the book would have you apply translations to the asymptote equations. I am not. If you can get this point and understand that the asymptotes always go through the center of the hyperbola, I'm a happy camper. But when you're checking your answers in the back of the book, they're often going to have an H and a K because that's what it's going to take to get you to the center of the parabola. By definition, a hyperbola, I'll draw it orange, is pushed by its asymptotes and its two curves. Okay, in theory, they both look the same. Mine's pretty crappy. The distance from the center to the vertex is A, so its transverse axis, which is going to be this axis right here, has a length of 2A. Okay, C is going to equal the distance from the center to the focus. So just like our other shapes, the foci are going to be on the inside of the curve. So my C is going to be the distance from the center to the focus, okay? And then this distance would also be C. So C is going to equal the distance from the center to the focus, okay? Alrighty. Now B is a little bit weird. So technically B is an intersection and it creates this cool little box in here. And this distance right here is B. So we often don't use B to help us draw our equations. We do need it for our asymptotes, but it is just kind of an interesting thing to notice. We have another cool little equation that says C squared is equal to A squared plus. Notice that this equation is positive instead of minus, okay? I'm just going to write it again. Our asymptotes are going to be y is equal to plus or minus b over ax, and this is from the center. If the center of the hyperbola moves, then that means that the equations move, but I'm always going to write them in terms of the center, okay? My generic equation is going to be x squared over a squared minus y squared over b squared is equal to 1. So unlike the other shapes, like when we did an ellipse, the largest number is not A. A is going to follow the positive variable. And the positive variable is going to determine your transverse axis, meaning the orientation of the hyperbola, okay? And then, of course, we can translate this. So this is h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Okay, so now let's talk about the vertical hyperbola, or hyperbola, however you choose to say the word. Hyperbola is the correct pronunciation. So here's my coordinate axes. Okay, this is going to be my center. Okay, I'm going to have a vertex here, and I'm going to have a vertex here, noticing that the distance in between is going to be your A. So A is the distance from the center to the vertex. Here's going to be my asymptotes. The asymptotes push the steepness of your hyperbola. Okay, this one looks a little bit better than the last one. The last one was kind of crappy. Okay, the C, my foci, are going to be on the inside of my curves. So my C is going to be the distance from the center to the focus and the center to the focus. So A, my transverse axis, is still going to be 2A. C is the distance from the center to the focus. I'm still going to have the same little equation, a squared plus b squared. We use this to help us find the missing pieces. My asymptotes in this case are going to be y is equal to plus or minus a over bx, noticing that the a and b switched from what they were in the horizontal. And then I'm just going to jump straight to the equation that's translated. I'm going to write y minus k, quantity squared over a squared, x minus h, quantity squared over b squared is going to equal 1. Important thing to notice about the hyperbola is that a is always with the positive variable. All right, let's do our first example. So example number 1, I want to sketch, except I forgot the C, sketch the hyperbola. And then I'm going to label all relevant information. Alrighty, so I'm going to be given the equation 4x squared minus y squared is equal to 16. But if you'll notice in the original formula, I have a 1 on the right-hand side, so I'm going to divide both sides of the equations by 16. And on these, the division is going to happen upside down. So instead of writing 4 goes into 16 and writing a number, I'm going to do x squared over 4 minus y squared over 16 is equal to 1. So for this particular hyperbola, notice that x is positive, so that means that I have a horizontal hyperbola. Its center is going to be the origin because I don't have an h and a k. My a, I'm going to write a is equal to 2 and b is equal to 4. On these, it doesn't matter which one's bigger. It just changes the shape of your hyperbola. I do need to find c because c is going to be the distance to the focus. So c squared is a squared plus b squared. So c squared is going to equal 4 plus 16, which is 20. Okay, and if I needed to solve for c so I could put it on my graph, it's the square root of 20. And then I could just push buttons on my grapher to find out what that decimal equivalent actually is. Okay, all right. So now let's go ahead and sketch. So here's my axis. I know that my center is at the beginning. A is 2, and remember A is the distance from the center to the vertex. So here's my 2. You always want to label it because a graph without numbers is just a pretty picture. Alrighty, and I'm going to put a dot there for the vertices, and I'm going to label it with a V. Alright, for a horizontal hyperbola, my asymptotes are going to be y is equal to plus or minus b over ax. So it's going to be plus or minus 4 over 2x. So plus or minus 2 over 1x. And I'm leaving the 1 just so we can see what I need to do when I'm graphing. So I'm going to go up 2 over 1. So here is going to be one of my asymptotes, and then down 2 over 1. Here is the other asymptote. It's important that you draw these well because we want to have a relatively accurate picture. Here are my curves because they go through the vertex and they're defined by the asymptotes. My focus is at 2 radical 5. I don't know exactly where that is, so I'm going to put it here, and I'm going to label that at 2 radical 5, and that's my focus. And then I'm going to label this at a negative 2 radical 5, and that is my focus. Okay. I'm going to label my asymptotes as y is equal to plus or minus 2 over 1x. I know the 1 is a little bit silly mathematically, but it does help me to draw a very nice hyperbola. Alrighty, I think that's everything that we need. So let's move on to our second example. So for example number 2, we're going to do what we've been doing in our other videos. We're going to find the standard form of the equation of the hyperbola, and they're going to tell us that I'm going to have a focus of, with foci of a negative 1, 2 and 5, 2. So those are both of my foci. And then I have vertices of 0, 2 and 4, 2. So my goal is to write the equation. So just like everything else, the best thing to start with is a graph. So I'm going to start by labeling, actually I'm probably going to start with my vertices. So as I draw my coordinate system, okay, 0, 2 is going to be a vertex. I'm going to put a 2 and a V, and then I'm going to have 1, 2, 3, 4, 2. So this is going to be another vertex. So since my vertices are at the same height, I'm going to sketch a line, do it in green, and this is just going to be the center, and I'm going to have a horizontal hyperbola, okay? The distance between here is 0 and 4. That means that the center is going to be at 2, so I'm going to label it with a center. I don't put a C because C represents the distance from the center to the focus, so sometimes I think it's just better to write the word center. My foci are at a negative 1, 2, so there's a focus. And then my other one is at 5, 2, so there's the other focus. It is a horizontal ellipse, hyperbola. So that means that my asymptotes are going to be y is equal to, what are my asymptotes? There they are, plus or minus b over ax. So remember that a is the distance from the center to the vertex, so I know that a is equal to 2, and c is the distance from the center to the focus, so I know that c is equal to 3. I need to find b. My baby equation is c squared is equal to a squared plus b squared, so b squared is c squared minus a squared, which is 9 minus 4, which is 5. So my b squared is going to be 5. It's a horizontal hyperbola, so it's going to be x minus h quantity squared over a squared, y minus k quantity squared over b squared is 1. Now I know everything. I'm going to write my coordinates for my center. My center's at 2, 2. So now I can fill everything in. It's going to be x minus 2 quantity squared over a squared, which is 4. Remember, a doesn't have to be the largest number like it does with an ellipse. A just has to go with a positive variable, and then minus y, my k value is also 2 quantity squared over 9 is equal to 1, and this is my standard equation of the hyperbola. Okay, there are some really pretty cool pictures out there that talk about where a hyperbola comes from if you bisect a cone. So we want to mention the eccentricity of a hyperbola, and the formula is still, it's going to be E is equal to C divided by A for a hyperbola your E is going to be greater than 1. Okay, and again, not a huge thing right now other than confirming our shapes, but we will talk about this later in the chapter. All right, I have one more example for us. So example number 3, and I want to find the same thing, the standard form of the equation of the hyperbola. And this time they're going to have having vertices. So they just changed the conditions that they're giving you for each problem, and 3, 1, and they're going to have asymptotes of y is equal to plus or minus 2 over 1x, and remember that that's going to be from the center, okay? Alrighty, so again, before I do anything mathematically, I'm going to sketch. So here is my coordinate system. I'm going to mark my vertices. I have 1, 2, 3, and then 1, 2, 3, 4, 5. So here is a vertex. And then the other one is at 3, 1. So that means that I have a vertical hyperbola because my trans-axis is vertical. So I have a vertical hyperbola. Sometimes brain and mouth don't work at the same speed. My center is going to be halfway in between, so this is 1, 2, 3, 4, 5, 6, so 1, 2, 3. So my center is going to be at 3, negative 2, okay? So pretty easy so far. Since it is a vertical hyperbola, I know that my A is going to be 3. That's the distance from the center to the vertex. And I know that this is kind of an interesting situation. They give you that my asymptotes are y is equal to 2 over 1x, which is a over bx. Well, if I put my y value of 2 is equal to 3, there's my a over my b, okay? I get b is equal to 3 halves. So now I think I have everything that I need. Alrighty, so this 2 is the y value, okay? Alrighty, sorry, I'm just looking at my math to see if I've done my math well. So now I'm going to use my equation. Because it's a vertical hyperbola, it's y minus k quantity squared over a squared is x minus h quantity squared over b squared, minus equals 1. So now I know that my center is, so I know my h and k, I know my a and my b. So I'm going to write y minus plus 2 quantity squared over my a is 3 squared is 9 minus x minus 3 quantity squared over 9/4 is equal to 1. So I'm okay if you leave it like this. You might see this piece written as 4 times x minus 3 squared over 9. And it's okay if you go ahead and manage this fraction. Just understand that if you take the reciprocal of that is what you're going to get for your b squared value. Alrighty, so there is our standard form of the equation. Standard form of equation, and it is our hyperbola. Alrighty, that's it for today. That's been kind of cool learning about all our different shapes. I will see you soon.